in the blue cell here, you can see it will tell you the number of bags of IMA. They're 21 kilogram bags. You can see here. And it also gives you a calculation for linear velocity. So if you go to your selection of filters, you can just change the yellow cells here. And say, for example, this is for a diameter filter. Amit, what is a normal size filter that Shanghai would supply? What's a normal stock item, diameter filter?
Okay, you're talking about FRP tank, right?
Yes.
So normally our clients, we have our smallest FRP size is 10 by 54, and our biggest is 63 by 86. We have 4 brands that we carry, Pentair and other brands. But one of my engineer, Engineer Ronald, one of our clients, what did he use for his system? A stainless system?
Mild steel.
Come here, come near me so he can hear. What did one of our clients use when he bought from us?
Steel tank.
Steel tank. What size?
Usually, diameter is about 86.
86 the diameter.
Inches.
How about the height?
Inches.
86 inches. How about the height?
Height is 72 inches.
72 inches. For what application?
Iron and manganese removal.
Iron and manganese removal. So of course,
Very good.
it's Pyrolox, Burl,
Yes.
DMI,
DMI.
or manganese green sand, right?
Yes.
Either of the 4. Any questions, my friends? So this engineer of mine has already worked with some of my clients on site, because what we do, James, is we just don't supply the products. We also finance the project, meaning our client will tell us, hey Amit, I have this mild steel guy, but I have no money. Can you buy it for me? Then we just monitor the project if indeed what we paid for is going to the project or is the customer pocketing it. So my engineers witnessed that.
Yeah. So, thank you very much for that contribution. An 86-inch diameter vessel, yeah?
Okay.
An 86 diameter vessel is 0.21844. That's a conversion. It's how many meters? 86 inches, is that correct? Is the diameter?
Is
Yes.
it correct, engineer? Ronald?
Times 2.54 equals, you can see here, filter diameter in meters. Okay, so you put the value in here, 0.218. Okay? And then you add the number of filters. This filter might have 2 filters, it might have 3 filters, and you can see the surface area is increasing, but in this case we'll just work on 1. And if you have a bed depth of, say, for example, 0.8 millimeter, 8.8 meters, yeah, that's the minimum for manganese removal. That will require 2 bags of DMI 65, IMA 75.
Okay, hold on. Let's see what engineer has to say. Engineer, what do you think? Is that what happens on site?
How many
2 bags.
tanks?
How many tanks? Is this for 1 tank? For each tank? For each filter?
Yeah, per 1 tank.
Per one tank.
For 1 tank na 86 inches and 72 inches, 2 bags.
How
Let's
many?
have a look at this one.
Too much.
Is that too less? Too much? Or
Small.
it's too less?
Less, yeah.
It's too less.
How
does-
what's
how
the-
Maybe is that correct? The filter diameter should be 22.18 meters.
22.18 meters.
2.18 meters.
It should be 2.18 meters as per my engineer.
Not 0.28.
Not 0.218. Maybe it should be 2.18.
2.18. Yes, sorry, beg your pardon.
Okay.
There you go.
Yan, 200
Lucky we have the engineer on site.
Good. At least we know that my
So this
guys
is a cut,
know.
2 meters, correct. 2.18 meters, thank you very much. So then you need 213 bags of IMA. So that is the equivalent of 4,479 kilograms. That's 4.4 tons. Okay, because the bulk density is 1.5, that's the total litres. This calculator will help you determine how many bags according to the diameter of your system per filter. For example, if this system was 3 units in parallel, you can change the number of filters there and it makes the calculation.
Ah, nice.
640 bags, okay?
So can we share this to all our whoever buys IMA 75 from us? Can we share this file to them?
Yes, of course. This is your calculator. You can use it for your customers. You can train your engineers.
And we can give the file to our customers so that they can compute it themselves, right?
It's up to you.
Okay.
I think it really helps.
Okay. Wait, hold on.
Now,
What's your comment, Jim?
Now-
How would our clients compute? Or I can ask questions.
The assumption is, what is the iron in manganese?
yes. So according
PPM.
to your raw water data, obviously the higher the iron and manganese concentration is the lower the linear velocity. Obviously, the lower your iron and manganese concentration, if it's only small, you can afford to run a higher linear velocity. Now this also provides a calculation for linear velocity here in F2. And this is the value here. Now, what I want you to understand is if you design a system that can tolerate iron up to say 10 parts per million, you can run at an LV of 10 cubic meters per meter squared per hour. And this is the LV figure. So this would equate to something similar to 600 litres per minute. Can you see how the LV value has now changed? 9.64 cubic meters per meter squared per hour. This is the LV, this is the linear velocity through your filter.
So just to clarify, James, because I'm not an engineer, I'll just ask my engineer. The reason if the iron concentration is higher, the linear velocity needs to be lesser so that the contact time is more. Is that correct? Is that the logic?
That is correct, yes.
Okay. So that the contact time is more and it can oxidize more, right? That's the concept. Okay.
Correct.
Okay.
And let's say, for example, because iron is very easy to remove, iron is instantly oxidized with air or chlorine or your calcium hypochlorite brand that you supply.
Yeah.
Let's say, for example, you're trying to remove manganese, and manganese is much more slower to oxidize and much more difficult to remove. So it needs a slower linear velocity. For example, if you're trying to remove 2 or 3 parts per million of manganese, the linear velocity should be about 5 cubic meters per meter squared per hour. So this filter, while it's the same size, if you're trying to treat manganese, it should be running at a velocity similar to, say, 311 litres per minute for an LV of 5. So you can use this calculator, and what we'll do, Amit, is we'll give another table to the side for some guidelines according to raw water quality for iron and for manganese. Okay? So in this scenario here, if you wanted to increase your efficiency in your 86-inch filter, you can go a deeper bed depth. You can make it 1 meters.
Ano yung bed depth yung grabe?
It will need an extra few bags, 276 bags. The LV remains the same regardless of the bed
Ano yung
depth.
bed depth doon?
Obviously, a deeper bed depth gives you
1 meter.
1 meter bed depth here will give you 20% more filtration efficiency for manganese removal without changing the linear velocity. The trade-off for this is you'll need more water in the backwash velocity.
Can
Let's
you,
have a talk about backwash velocity.
my friend, can you show us like, because my salespeople are not really, my salespeople are mostly women and they're not really technical. So instead of being technical, they like to win the heart of the customers because they're men. So I need to have pretty salespeople to win the heart of the men engineers, right? So that's how we roll here in Shanghai. So now, can you just show them a simple drawing, like a whiteboard of how an FRP tank looks and the bed depth and where is the gravel and where is the iron there and how you put the water first, then put the chlorine, then soak it, like just a drawing. Later on, just sharing to you what, let them have an idea also that so they see. So when a customer talks to them, I have an iron manganese project. Oh sir, okay, I have the tank, I have the silica, I have the gravel, I have the chlorine. So that's how they'll sell because they have a picture of how it looks inside. I have the bottom distributor, I have the, what do you call it, Alma? That connects to the riser. The laterals, you know? Later on.
No, I haven't got that prepared. I mean, you didn't ask for it, so.
Okay. Okay.
No.
problem.
If you need something like this, you know, it takes a little time. This is technical training.
Okay, no problem.
This is how you size up. So
Okay, understood.
look, if you need a presentation to help win your customers, you know, you need to get your graphics team and your team to start working on what you need. If you need
Okay.
technical guidance from me, this is how it looks.
Okay, understood. Continue, no problem.
Yeah, so just going back from, we've got ourselves this calculator. I'm going to send this calculator to all of you, and I think if your ladies need to ask how this calculator works, please do.
Yes.
Okay? When this is technical, and I'm trying to give you the very easy to use technical tools so you've got the answers. When we talk about a sales brochure or a sales training, we can work on that one next time.
Yeah, understood.
When you make your brochure and when you prepare your sales brochure, I can give you very simple, girls, ladies and gentlemen,
Yeah.
very simple golden rules. These are the golden rules how to use,
Okay.
and then on the other hand, the benefits, and the benefits are always the same: is high flow rates, high load capacities, long filter run times, these things. So
Okay.
what I think we'll do, and I can work with Amir and Alma,
Yes.
I'll give you the golden rules and the benefits, and then we'll have that as your sales go-to sales literature.
Yes.
And then on the other hand, it'll give you 2 calculators or 3 calculators, and one will be this one, the number of bags and linear velocity calculator. And the second one will be a chlorine injection calculator, or your product, how many tablets calculator.
Yes.
and perhaps a bed depth calculator like what Amit was saying, a nice picture of the filter
Yes.
with the filter bed depth and the freeboard, and it'll work out how much freeboard, how much bed depth according to how many inches. So you'll have 3 technical tools, and you'll have two or three go-to-market sales products. So it's like a brochure.
Yeah.
How does that sound?
It sounds good. By the way, we import our own calcium hypochlorite in pills
Yes.
and granules from India. So we have all
Yes.
the government regulations for that. But we buy locally the sodium hypochlorite. So sodium hypochlorite is in liquid form, right?
Yes, correct.
So we buy that when our customer asks for it, but we always try to tell them, hey, just buy the calcium because we're the direct importer for that. We make more money there. But they always ask us, okay, how do we? They're used to sodium hypochlorite. So when they ask me, okay, so what's the competition from switching? So that's where I have a hard time. That's hopefully you can also train us today. The dilution rate and all that. If you can. Yeah.
Yeah, so the golden rule, and we can I've had it checked out with the chemist. He said it's fine to use. The golden rule, and we've got a formulation for chlorine per parts per million per parts per million of iron, and the ratio is, if you want to write this down,
Yeah.
we can create a calculator per tablet, but the ratio is for every 1 part of iron, you need, every 1 ppm of iron, you need 0.64 ppm of free chlorine.
So everyone.
0.64 ppm of chlorine.
0.6
4.
chlorine, okay. Free chlorine, okay.
And for manganese, it's 1.3 ppm of free chlorine for every 1 ppm of manganese.
So you need more for manganese, basically.
Manganese,
More
you
chlorine.
need more because it's a lot more difficult to oxidize than it is iron.
Okay.
Now you can also, a golden rule is you need to maintain a free chlorine residual value of 0.1 to 0.3 ppm of free chlorine coming through the filter.
You mean at the end, after the when it goes
and
to
the
the
filtrate water.
basic. By the way, I want to share something with you. Just to break your presentation, I want to share something with you. So my company, we sell to a lot of, we have 300 dealers who build bulk water systems, wastewater systems, water filtration systems, iron manganese systems. So this is our product line. So we have deep well pumps, then we have the inverters, meaning if the source of the water, if the source of the power is DC, meaning solar, or the power company, which is AC. So we have those inverters. We have the pump. Then it goes to we have the chlorine system, meaning the mixing tank, the dosing pump, and the chlorine, of course. Then we have the tanks, the storage tanks, the stainless tanks. We sell that. And then we have the AFM filter. We're also the distributor of AFM. And then, if they can't afford AFM, we have Silica. And then, DMI. Hopefully, we'll switch it to IMA 75. Then they say, after the chlorine oxidizes the... Correct me if I'm wrong, this is the perfect system. My engineer told me, who's here. He said the perfect system is you oxidize it through chlorine, then you have a settling tank, a storage tank, so all the sediments go in the bottom. Then you have an AFM to filter the suspended solids. Then you have a DMI for the iron and manganese, which are very, very small. It will oxidize it. And then you have another AFM to trap it. And then you have a GAC to trap the chlorine. and then you have a softener to remove the calcium magnesium, and then you have a UF to remove the sediments, and then RO to bring the TDS from 0 to 10. Then if you want ultra pure water, cation, I have all the cations available, and I also stock the anion, and I also have mixed bed. So this is my business. I have all of this. Now, whenever I speak to customers, they play around. They say, I'm not gonna waste money having so many treatments. I'm just gonna combine the DMI and AFM in one tank. Then one guy says, no, that's wrong because the stratification, the density is a problem. So I'm a guy, I'm like a patient listening to many doctors, but not contradicting. I just listen, oh, so this guy is doing this. Oh, so this guy is doing that. So I'm just sharing to you the collaborative information I've gotten. So I was hoping if you could tell us the ultimate correct way so that when these customers come, I never correct them. I mean, if the guy is willing to buy everything from me, why would I stop the guy? It's business for me, right? So just sharing to you.
Yeah. Well, Amit, there's what you experience, I guess, and you would all know is water is very unpredictable, and in every case, it's quite different. So you've got a lot of solutions and a lot of great products, and perhaps in each and every case it's going to be a custom solution. So you're going to need your water treatment engineers to, in each and every case, be confident in their offering, and quite often for each customer and each raw water source, it might not need all of them.
Right.
Or it can be some. So you're going to have a look at the raw water matrix, and quite often, because we are media manufacturer and we don't supply the other technologies, we will have a look at a raw water matrix and say, this is what you need for iron, manganese, arsenic, other heavy metals. This is the linear velocity, this is the number of bags, this is the diameter of the filter you'll need. However, we will point out these are the things that could be a problem to the iron removal, manganese removal. These are the things that need pre-treatment. I really like what you're saying. A pre-oxidation tank is very useful. It's very useful because you can pre-oxidize the heavy metals, alter the pH if you need with caustic soda or sodium hydroxide.
Yeah.
It might need some coagulation. You know, you might be drawing river water or surface water that is high in suspended solids and needs some PAC or some coagulation. So a pre-treatment tank is very good. Now, whether you have to run that through a sand filter or a glass media filter is up to you, up to your client. So, and that's where our recommendations really stop. We will say, yeah, you'll need to pre-treat the suspended solid, the turbidity, and these other contaminants. We can give you some comment that you need to pre-treat that water, but we're not going to tell you how, because we don't make the equipment, we don't supply that equipment. But I'm happy to say this will need pre-treatment, and we give you that service.
But how about this argument when I speak to customers? When I tell them, hey, you know what? I spoke to another customer and he's like, AFM glass media before DMI, after pre-oxidation, because you don't wanna stress out the DMI media. So one guy says, no, DMI has TSS removal features. So is that true? Can DMI remove TSS?
Up to a certain point.
Okay.
So,
Up to what micron?
you know, we can see, you know, after 10, 15 ppm TSS, it can remove down to less than 1.
Oh.
You know, do you need to have a sand filter or a suspended solids filter before? It's up to you to provide that solution for the client. So, yeah, we're happy to offer that advice, but we can't tell you how.
Okay, clear.
It's because IMA 75 is a silica sand-based material. It is the same coefficient and particle size as sand. So it is going to have excellent mechanical filtration.
Okay.
And quite often it has excellent catalytic adsorption properties of iron and manganese. So case by case, you might find that you can do with just a DMI filter the same as a suspended solids filter, iron removal filter, and an RO downstream, depending on what the raw water is like.
Okay.
So it is case by case.
And another guy says, why are you gonna put chlorine? Since DMI is catalytic, let DMI do the job of oxidizing. There's also another argument that for small systems, because aside from industrial customers, we have a lot of water filling stations. Okay? This is the design of a water station.
Yes.
Uh,
Well, you can
this one.
you can go one step further.
It's not so
say
Yeah.
the role of the sodium hypochlorite or your calcium hypochlorite tablets is to protect the media from iron biofouling. Have you ever seen red sludge from iron? Have you ever seen the red slime caused by iron?
Which looks like it looks like corrosion, right? Yeah.
Yeah. So the chlorine helps protect the catalytic surface of the media.
Okay.
That is it. One, the chlorine helps pre-oxidize the iron and manganese in the raw water, but it also stops. The chlorine is slippery and it creates a membrane, a protecting layer over the catalytic surface of the media and prevents iron biofouling from sticking to the media.
Okay.
Excuse me one sec.
Tama siya. Tama na sabi niya.
ano niya yung para hindi siya
Okay. Yeah. What's
you
that?
see the color of this?
Yeah, it looks brownish.
It's brown.
Yeah.
Well, this is filter media that's totally coated in iron.
Okay.
There's no chlorine being used in this. And eventually the iron that passes through the media, it sticks to it.
Okay.
And once it's completely coated, it's almost impossible to remove. This is what happens when you don't dose chlorine.
So what happens? The flow rate drops, right?
Well, what eventually happens is that it becomes completely saturated in iron,
Yeah.
and you stop removing iron.
It
Iron
breaks through.
starts breaking through the filter.
Okay.
Once this happens to your media, it has to be replaced. It should always be black.
Wait lang. Ansa?
Ah.
When there's always chlorine,
Alright.
it's always black.
Clear.
Yeah. And so the chlorine protects the media from getting coated in iron. As long as there's chlorine, if you always maintain a free chlorine residual value of 0.1 to 0.3 ppm coming out of the filter, it's protected.
Okay, clear.
That's why it lasts a long time. 15 years.
Kaya? Figure.
Mate. So this is why we want to maintain a free chlorine residual. And if you come across a stubborn client that says why do it? Because straight away they'll get the good results with just air oxidation, perhaps no air, but they might get the result they want. But over time, if the iron biofouling, the red sludge, the fouling starts to grow in there,
Yeah.
it will totally coat the media, and eventually it's rubbish.
Okay.
It's at their cost.
and we have to replace. There's no way of regenerating the media.
No, I mean, at early stages, say for example, the chemical dosing pump fails or the customer doesn't use a chlorine tablet for a little while.
Yeah.
You can reactivate the media. You can clean it. You can backwash it with chlorine and it comes good.
Oh, that's
But
nice.
if it becomes like this, it's too late.
It's too late.
Yeah, this is like 6 months, 8 months, no chlorine, too late.
Clear.
It works for a while, but then, you know, and it is different in every case. It's different in case by case. Sometimes there's only a tiny amount of iron in the raw water, and you might get away with it for a long time. And everyone's experiences are different. If you've got one person that has one application, they have a long time, no chlorine, no problems, they're probably going to believe they're doing it the right way.
Yeah.
But you know, for sales technicians and engineers that have done many different applications, you start to understand what works better than others over many applications. And we've done thousands of applications all around the world, and the best applications, the ones that work the best, and the ones that work the longest, and the ones that have no issues, all maintain a free chlorine residual value of 0.1 to 0.3 free chlorine residual, and they get very good results.
Very clear. Thank you.
Does anyone have any questions that they'd like to talk about? Is there any questions about how to use a DMI filter or an IMA 75 filter?
Dun sa
Wait, let me just convert this up from the local language to English.
utilization kasi niya. Paano ano ba 1 ppm yung iron, 1 ppm yung manganese?
Oh.
Ano ho tawag doon? 311 nakalagay doon kasi sa kanya.
So if the raw water has 1 ppm iron and 1 ppm manganese, what's the rule of thumb to compute? That's your question.
Yes.
Well, 1 ppm of manganese is the problem in that scenario. 1 ppm of iron is very easy to remove. So if it was iron alone, you could run at a much higher flow rate. You could probably run an LV of 12 or even higher. Manganese is the problem here, and this is the reason why. When you oxidize iron with chlorine, it changes from ferrous iron to ferric iron. It changes from clear iron, you can't see it in a bottle of water.
From soluble state to insoluble state.
Exactly, from ferrous iron to ferric iron, it changes instantly with it coming in contact with chlorine. And it changes to a crystalline structure called ferrous hydroxide, a crystal. And it retains all in the top surface of the filter, the very top. It all gets trapped on the top. So it's complete removal. So you can use much faster flow rates, smaller surface area filter. It's easy. We all know it's easy. But 1 ppm manganese is a nuisance. It's tricky. It's very dependent on flow rate. It needs a slower flow rate. It's very dependent on bed depth. It needs a deeper bed depth. Why does it need a deeper bed depth? Because it's slow to oxidize. It needs more contact time through the filter media bed. It's not retained all in the surface. It's retained right through the layers from top to bottom. That's why we recommend not a 600 millimeter bed depth, an 800 millimeter bed depth, because the filter media is retained from the top to the very bottom.
When you say bed depth, that's the hole from top to bottom of the DMI filter, right? The IMA filter.
Correct.
That's it.
Correct.
Top to bottom.
Correct.
And freeboard, I'm asking these questions for my sales girls, huh? And freeboard, so if there's an FRP tank, it starts with the freeboard. No. If there's an FRP tank, we start from the bottom. So it starts with the laterals, right? And the strainers.
Yes.
Then the gravel to hold it, the bed. Right? Then you put the DMI or the IMA, which is the bed depth, right?
Yes.
then the
Yes.
freeboard.
Correct.
So,
The
nag-gets nyo?
underbed gravel, the
Yeah,
support layer of gravel
yeah.
should be so that it's about 100 millimeters or 4 inches above the laterals. So you completely cover the laterals with underbed gravel.
Okay, I'm just writing it in our whiteboard now. Then?
Yeah.
Okay.
It's about 4 inches, so it completely covers the bottom laterals.
Okay.
Then the DMI and those particle sizes, Amit, should be about 1 millimeter to 3 millimeter particle size.
The mesh size of the gravel, right?
Or I don't know, I can't recall the mesh size off the top of my head, but it's particle size 1 millimeter to 3 millimeter particles. Riverbed gravel, something like this.
Okay.
Those gravels don't move. When you during a backwash, they don't move. They just sit.
Yeah. There's a gravel bed. Yeah.
And then sitting on top of the underbed gravel is the IMA filter media, and we want a 600 millimeter bed depth for iron minimum,
Okay.
800 millimeter bed depth for manganese minimum,
Okay.
and for very dirty water, we like to recommend 1 meter bed depth.
Ah,
And
okay.
that might be for iron, manganese, and suspended solids. You know what I mean?
Yes.
So if you've got tricky to treat water, go with 1 meter bed depth.
If the water
Don't go any more.
If the water is a challenge water, like high iron, high manganese, lots of, like, basically a river water with a lot of pollutants, right? Okay.
And then above the DMI, you need to have a minimum of a 40% freeboard. And we're going to give you a calculator, a bed depth calculator, so that you can enter the height of the vessel, and it will tell you the height of the DMI, the minimum freeboard. And the reason why we have a minimum 40% freeboard is because that's what you need. You need a minimum of 40% bed expansion during backwash as the resting bed height, 600 or 800 mils. When you backwash the media, it rises 40% of its bed height, so that all the particles inside the filter all turn over. And that's how you clean the media, and that's how you release the iron and manganese to the waste tank, the backwash waste tank.
Okay.
There's a problem that people experience when they have a small filter. They often think the more DMI the better, and they fill the media right up to the top. They fill it right up to the top, and so there's no freeboard left in the filter. They think that the more media the better. But the problem is you can't get any backwash expansion because you've filled the vessel right up. And if you can't expand the bed, or the particle size can't freely move in the bed, it means that you're not going to release the iron and manganese to waste. No part of the iron and manganese stays in the filter. You need to wash it all to waste in the backwash cycle.
Yeah.
And the backwash cycle is calculated by pressure differential or time. So you can tell your customers that once a day you backwash your filter for 10 minutes, and then it is ready to go. And no part of the backwash or part of the filter run, the catalytic surface is reduced, and no part of the iron or manganese stays. And that's what makes this media special. So you can tell your customers that you backwash your filter once a day for 10 minutes. Or, for your engineers, you can automate the backwash to a pressure drop or pressure differential of 50 kVA. And that's how you answer that question. When do I backwash? Once a day for 10 minutes. Or you can automate the backwash to a pressure drop or a pressure differential. And that what happens there is, as during your filter run, as the iron and manganese is trapped in the filter, the pressure differential, the pressure gauge of the water coming in and water going out will increase in pressure as the filter loads up with iron, manganese and suspended solids. And once it hits a
15 psi.
differential of 50 kPa, it then switches to backwash and it cleans the filter.
But is there such a head? I don't have such a head. Are there heads that do that just on pressure?
You
Or you have to
can,
compute it manually?
you can get an automated head, like a Pentair head, but if you don't have them and if you're all manual, you can do two things. If your operators are all manual and visual operators,
Yeah.
what you can do
Put an
is
oil
you
gauge.
can-
Put an oil gauge before and after.
Yeah, that's right. You can get them to watch the pressure gauges and you can work out time. How long does it take before, in your first filter run, for you to achieve a pressure differential of 50 kPa? And then you can tell the operator that you need to do a backwash every 18 to 24 hours. Something like this.
Okay. Hold on now. My laptop is low bat. Hold on now. Let me just find a charger. Just 1 minute break. Ano, walang power adapter?
Well, I
Hold on ah.
actually, ladies and gents, for today, I've actually only got five more minutes. So, has anyone got any questions? And we can follow up with some literature, and we can have another training at another opportunity if you like.
So just to confirm, 50 kPa as in 50 is the pressure difference.
Engineer, sige, ask your question. What's your question?
Just to reiterate, 50 kPa pressure drop or 50 is
50 kPa pressure drop, 50.
okay. So I read some of your case studies. You also remove the DMI also removes copper and zinc. Is
Wala.
that true?
It is correct, yes.
So how many ppm does it remove?
It can remove if you've got a slow flow rate
Wala.
and
Kanino
a
wala?
800 millimeter bed depth, and you've got a flow rate of
Saan?
about 7
Kanino
to
adapter?
8 LV.
Nagsasara na.
We've been able to move up to 20 parts per million.
Come again, sorry. 7 to
20 ppm of
20
copper and zinc, and the parameters that we did that at was at 7 to 8 meters cubed per meter squared per hour, with a bed depth of 800 millimeters. And we're actually able to achieve that at a varying range of pH, so it's got a wide pH range. So it can remove copper and zinc very well, very, very well.
And can INA 75 remove arsenic?
Of course.
That's why I named it
So-
INA. Iron, manganese, arsenic, so it's easy to sell.
Very good. I like it.
Yeah.
So arsenic is a big problem. Arsenic, and we'll wrap up on this one, and I'll have some. Obviously, we'll have some summary emails going back and forth. We can do another training, but this is a good one to remember for people. Arsenic is a class 1 carcinogen that will create cancer,
Okay.
and it's type 3. Arsenic type 3 is the problem arsenic. And what we do, because it's only a very tiny molecule, it's in the parts per billion. It's in the parts per billion, and most technologies out there is usually reverse osmosis.
Yeah.
It's high energy, it's costly. DMI 65 and IMA 75, we call it IMA 75, can remove arsenic to drinking water quality at a fraction of the cost of RO. A fraction of the cost. but it doesn't do it alone. Science tells us that the arsenic molecules are like brother and sister with iron molecules.
Oh.
Arsenic type 3 and arsenic type 5 will attach themselves to iron molecules. Now, in nature, sometimes there is already iron in the raw water, and those arsenic molecules will attach themselves to the iron naturally present in the well or the borehole. And in those cases, we can use by direct filtration through our media. Where there is no iron present and there is arsenic present, we have to introduce iron in the form of liquid ferric chloride. And there is a ratio, there is a chemical dosing ratio, and this method of removal is called arsenic removal by co-precipitation with iron. And the ratio of ferric chloride we need to dose is 50 parts ferric chloride to every 1 part arsenic. So, in a practical sense, for example, if there's 100 parts per billion arsenic in the raw water, we would dose 5 parts per million, 5 ppm ferric chloride. Okay, and that's enough for it. What that does, it acts as a coagulant, because ferric chloride is a coagulant, is an iron-based coagulant. You can actually use ferric chloride or ferric sulfate. Ferric chloride is FeCl3. Ferric sulfate is FeSO4. You can dose 50 parts ferric chloride or ferric sulfate into the raw water, and the coagulant will bind up the arsenic, and then you can filtrate it through the DMI 65 in the same way you would remove iron. You still need to dose chlorine, same golden rule, maintain a free chlorine residual value of 0.1 to 0.3 ppm coming out of the filter. But this is the way you can remove arsenic with ferric chloride through our media. And this method is a fraction of the cost of the reverse osmosis membrane solution.
Okay, but
I can give you
I lose my RO business then. Kidding. Okay, before we wrap up, my friend. Okay, engineers, if you have any question, I want to finalize the bag today. So, can you look at my bag, my friend, and tell me if it's already good? Like, my final brand name is IMA 75 Advantage. So, I sent it to you in our group chat. And engineer, if you want any comments. You think we're good to go with this bag?
Did we make the changes we suggest last time?
Yeah.
Let's have a look. Let's go.
Let me know. If you can walk through it and let me know what you think about it so we can already move forward, because I have a lot of customers already waiting for this. Because we sell a lot of Pyrolox, Verb, so we wanna keep just one because it's our own brand, right? We wanna come back.
I think you've done a wonderful job.
Yeah. You can fix it whatever you think is correct, so at least we stick to this bag maybe for the
I
next
believe
5 years.
There was only Alva and I spent some time on this before.
Yeah.
And
See, we're not very technical. We're like we're good.
I think it's a beautiful bag.
We're good in
Yeah.
copying, so we're getting literature from everywhere and just putting it in one,
Yeah. There was okay, that's good. I can see you made the activation changes. It's very good. You put in yes, precautionary statement.
I removed the carcinogen statement because in the Philippines when you say carcinogen, everyone starts to panic.
Oh, I've got that was my suggestion too.
Yeah.
Look, it's good to go. If you could please send me through the file so I can send it to the bag manufacturer. They need to develop a printing plate. I think it's ready to go, and
I'll send you the file. Then maybe if I could request you to just walk through it one more time, If there's any
Yes.
spelling problem or percentage problem or micron this, then final proofreading, then it's good to go.
We will proof it for you.
Please, because we're not so technical. We're more of a distribution company. Our technical team, I'm not saying we're weak, but we're not there, you know? We're just good at understanding, like,
Appreciate it.
what do you need? We're only good in asking our clients, what do you need? Okay, we'll find it. That's our specialty.
I guess you've done a great job on the bag, and the brand is great.
Yeah.
And you're going to get all kinds of questions, it seems, at first.
Yeah.
I'll support you with helping you with the questions. But what you will find over time, the questions are all the same.
Yes. It
And
keeps.
the beautiful thing is,
Yeah.
the answers are always the same.
Right.
And I talk repetitively like this only because it helps you understand
Yeah.
and get you the one-liners and the two-liners and the answers, because you'll find the questions are always the same. The applications are all different. The calculations and tools are there to help us work out the differences, but the answers and the selling points are always the same. We can practice these later, lady, and what you'll find is the selling points are the same, the questions are the same, the answers are the same. After a while, it'll become easy.
Okay, I have two more questions before we end. Engineer, your last two questions.
Okay, so
Here, sit down here.
Alright, so last two questions. So we have a client that is supplying bulk water to some cities here at the province. So he's using deep well, around 40 horsepower for his submersible pump, and then he produces around 30 liters per second for the whole community. So for that, he is injecting chlorine around 1 to 2 ppm, and then it is being catalyzed. But first, it will go to a reaction loop. It's just a piping, sort of piping.
Like this. It's like a loop.
Yes,
Yeah.
it's like a spray.
Yeah.
Like how a static mixer works. Yeah.
Yes.
I understand.
Yes,
Understand.
reaction loop, and then goes into the stainless steel, the light steel tanks. So for that, he doesn't have any huge cistern tank to have the chlorine contact with the raw water. So it doesn't have time to precipitate and things like that. So I'm asking if the reaction loop will do or will suffice. So is it viable for bulk water suppliers to replace cistern tanks with reaction loops?
Well, the use of sodium hypochlorite in chlorine in a loop like that is going to get very good oxidation in the loop prior to the DMI. So obviously, if it goes from the well straight to the DMI, that's a short contact time. But if you've got a loop and it's recirculating, that's going to get very good aeration and chlorination through there. So it is a clever solution.
Mm-hmm. So
The only time I could suggest a tank to be better would be if you needed the detention time and the settling time. If it was really high iron and really high other concentrations, and you needed some contact time in the tank for the contaminants to settle out in the tank and drop to the bottom of the tank, and you draw off the surface water and then polish with the DMI. That's one engineering method that works really well. But if it is just, say, for example, up to 5 ppm of iron or even half a ppm of manganese, that contact loop would work very good. So if it's there they're already using something like this, or it's a solution that you can offer, you could probably put it in and you could test it. You could do a simple test to see how it oxidizes the iron. You could just do an iron test of it after the loop, and then you could probably use that in a jar test with DMI or a little column test. So you know, it is a solution, and it's obviously
tumatawag ng for
saves a
7, hindi
footprint
binibigay
on,
ng
and it
for
saves
kasi
cost on buying a tank. So
sa
you've got a good solution there. Yep.
Okay, then that was Engineer Arby's question. Then the last question, Engineer Ronald. Don't be shy.
Yes.
So you can speak Tagalog, English, go ahead, and I'll just translate if it's hard.
Yes. My question is because different client has different ppm, say 1.2, 1.5,
For what? Iron or manganese?
iron and manganese.
Okay.
So, the linear velocity based on your calculator, we will 12, I think you told yesterday, a while ago that should be 12. Is that the rule of thumb? 12, I think, cubic.
Cubic per hour.
Well, it is cubic meters per hour. I tell you what, sir. We'll give Amit a table, a guideline, some suggestions of operation. So you can have a look at the table, and if you know your raw water concentration for iron and manganese, you can look at the table. It will give you a suggestion for linear velocity. You take the table, here the guidelines, then you can get your calculator and put it in, and you can make your design from there. Would that be good?
Yes, because we want to know the volume of the AMI 75.
IMA 75. IMA 75.
AMI 75. Yes.
That we will do that, and we'll make some very good guidelines to raw water concentrations, because today it's 1.5 ppm. Tomorrow you'll have another raw water
Yes.
source. It might be 5 ppm. It's going to be different. But we will give you some good suggestions of operation according to raw water concentrations of iron and manganese to give you the framework to use the calculator and get good results. Okay?
Yes. Because the pH is usually the pH is I think it's about maximum of 8 ppm.
Yeah.
To
Okay.
6.5 ppm, I think is that the range also of the
DMI can do up to 5.8, I think.
5.8.
So 8 is very good. You're lucky. It's good. So when the pH is low, less than 7, we really recommend dosing some pH control, to raise the pH. Caustic soda, soda ash, sodium hydroxide to raise the pH, because iron and manganese oxidizes faster at higher pH. So if your raw water is already pH 8, it's very good. You're going to get good results.
Yeah, we sell caustic soda. That's good for me.
It's good for you.
Yeah.
The limitation though is 8.5. Okay.
8.5.
Above 8.5 is getting too corrosive, and it's going to reduce the lifespan of the media, because what can happen, it can dissolve the catalytic filter, dissolve the catalytic layer. So you want to make sure that your optimum pH range is about 7.5 to 8.5 is the best range for iron and manganese removal, and it's safe for your filter media. Okay.
I think that's all.
That's all.
I'm more concerned on the quantity of the media that will be.
So we can explore the calculator when he sends us.
Yes.
Yeah, I will email to Alma the guidelines, and she can share with you and with the calculator. So it's an easy, quick look. I'll probably put them on the calculator. so that you can reference on the calculator and enter your filter size, your flow rate, number of filters. It will tell you the linear velocity and how many bags.
Yes, debugs.
Easy to use.
Yeah.
Okay.
That's all.
Okay, thank you, engineer. So we're good. Any more questions, girls? No more? Gina?
Hindi, yun Sir Amit, kung yung DMI 65, question nyo ng client hindi
Oo.
pwede din halo yung GAC.
Come here. This is the last question from our sales. She's a sales manager here. Come.
Yes?
She's a pretty girl. Hold on. Don't be shy. You can ask, go. Tulungan kita. She's asking, sige, if we can mix DMI and GAC. And
If
we
the
go.
DMI 65 can mix the other media like GAC, activated carbon,
In one filter.
in one FRP tank,
So people have done that before. It's a good question. And traditionally with other medias like green sand and firm, I've heard of multimedia filters where they use the carbon on top.
Yes, our clients do. Our clients always do multimedia with all our medias, meaning they'll mix it in one tank. They'll put glass media, they'll put DMI or a manganese or a zeolite. They'll mix up everything because they have space limitations. And when they put the iron manganese filter, it's by accident, meaning there's already a basic sand filtration, carbon filter, and softener. And after a few years, when they have an iron manganese problem, then they set up the iron manganese. So they have space limitations. Yeah.
So let me just, there's two things here. One, the DMI 65 is a sand matrix material. Its bulk density is 1.5, or AMI is bulk density 1.5. Specific gravity is 2.7. So if you mix that media with other medias like glass media or sand or something of similar weight, it is all going to get mixed up. When you put it in the filter, it's all in nice even layers.
Yes.
But when you backwash that media, it just mixes all together. And that's not a good thing because it creates channeling and it creates uneven distribution. So we don't recommend mixing our media with other media types.
Oh. Wow.
Okay? You don't need to. But, okay, here's the exception. Carbon and activated carbon and your other similar products like
Anthracite.
GAC,
Anthracite, James
it's a
Conley.
lighter material, okay? It's a different specific gravity. It's a different weight. So when you use DMI, 800 millimeters, and activated carbon, perhaps 200 millimeters, after a backwash, the DMI always falls to the bottom and the activated carbon stays on top. So you can use GAC or activated carbon with AM75. You can. So when your customers want a mixed media, it's usually for the suspended solids and the turbidity. Okay, you can use an anthracite cap or a GAC cap or an activated carbon cap, about 200 millimeters. I call it a cap because it sits on top of the DMI and the carbon on top.
So,
and you only really need
yeah. Sige, finish it. Yeah.
you only really need 200 or 300 millimeters on top.
So we can do. So when we do our multimedia and our customers ask us, we'll tell them you cannot mix DMI or IMA 75 with the same densities, right? Because when you do backwash, it starts channeling. But
It just mixes up.
yeah, but to avoid channeling, if they use a media which is a maximum of 200 mm, they can only use GAC because it's light and it must be on top of the DMI? And can they use anthracite too? So we already have, because they always use anthracite, GAC, and DMI. So, and silica. So can we put that all on top, or how do we work things out?
So there's no point using sand.
Yes.
You use the underbed gravel. It doesn't move. Okay, the support gravel we talked about on the bottom. Then you use DMI 65. You still need to maintain the minimum bed depth with DMI. If you're going to use a mixed media or not, DMI still needs the 600 to 800 millimeters minimum bed depth.
Okay.
And then you put your activated carbon or anthracite on top. And that's it. You only need underbed gravel, DMI 65, and then carbon if you wish on top. Whatever carbon product you can spec. Okay?
I'm asking because you can cap it with anthracite or carbon, correct? But DMI
Correct.
needs chlorine to activate. So I think
Yeah.
anthracite will be better for it if it will be used on.
Because if you put a GAC on top and there's free chlorine,
yes,
the GAC will absorb everything.
There will be no chlorine.
That's correct. So that's a great point, and from an engineer, thank you, because that's normally why, as a manufacturer, we don't recommend mixed media. Because what the trade-off is, you're going to try and remove suspended solids or other contaminants in the carbon cap, but really what that's going to create, you need to maintain a free chlorine residual of chlorine coming out of the filter, and what's going to happen is you're going to be dosing more chlorine going in the top, and what is that? That just costs you more money.
So sabihin mo, ito lang gagawin natin. Ito lang recommend natin.
So
Yeah.
we can recommend actually on small filtration systems to use
200 mm anthracite.
200 mm anthracite and then 600 mm minimum of DMI or IMA. That will be the cheapest option.
Yeah, that's the cheapest option. So, very good.
Any more questions?
You've got a
James?
clever team, hey Amit.
Yeah, alam mo na.
You've got a good team. You've got a clever team.
We're trying. Okay? So thank you so much, James.
How about yung yung
Alma.
MSDS na chlorine natin, so pwede natin gamitin yun. Kasi sa juice kasi yung sa bago.
Alma has a question. Since we're already finalizing our bag, are you allowing us to put the NSF and ANSI 61 standards in the bag since the brand is different? Because just like Pentair, Pentair, we are the exclusive distributor of Pentair in the Philippines, my company. But Pentair also does for us some OEM tanks so that it's cheaper. But they don't allow us to put the NSF certificate there. So we want to clarify that with you.
Yeah, so the statement that you put there is you're compliant with the NSF ANSI 61.
So that's a safe
That's
statement.
What
Okay.
that's what we're allowed to use, compliant, the word compliant.
Okay, we're not
Because
stamping an NSF certificate. Okay.
otherwise we need to pay.
Right. I like this. Okay. Alma, what else?
Yun lang naman.
So no more questions from purchasing? Good. And then sales, any more questions? IMA? Dan? Engineer?
Sa ano kasi,
What?
yung sa DMI ba, yung pre-regulated.
Here, ask that. Before we end. Yes,
Kaya
another.
it was the same din yung
Ask him, don't be shy. Ask him.
for DMI 65, there is a word here that UK regulated. I think it's a UK regulated. For AMA, you will not put also the phrase UK regulated media. Because there is an certified, so it will be removed.
Yeah, no certification. Just compliant. Yeah, nothing.
Nothing.
Yeah. That's okay. We'll just hard sell it to our client. Anyway, we can sell it even if there's no certificate. It's easy.
For branding, there is NSF, 61.
Compliant,
Compliant.
not certified.
Compliant.
Yeah.
So also UK regulated compliance also.
You want to add that? Can we add UK regulated? Something like that?
Because that is also in DMI.
The UK reg compliant. Is that applicable though in the Philippines?
Some clients look for this.
Some client put it the technical specs. NSF certified in I think NSF 61.
NSF certified ANSI. So
IC 61.
ANSI 61. So we will put NSF compliant, ANSI 61 compliant, and UK compliant.
Yes. If it is possible.
Yeah.
Because that is
The word compliant is okay to use, yes.
So we'll just add that, the UK.
Yeah.
Good? We're good? No more questions? Okay, perfect. So James, I really thank you for being patient. I know we are asking too many questions again and again, but we appreciate your patience with my team. Looking forward in marketing this product and having a long-term partnership with you. Any do's and don'ts for us? Any do's and don'ts so that when you receive the goods, we won't make a mistake? Any do's and don'ts?
I think everything's fine. You'll find that your packages will be beautiful. The product will be terrific. I guess the do's and don'ts is how you use the media. We talked a little bit about it. You'll have some customers have an idea of how they want to use the media, but I guess we can just produce a how to use document with some golden rules. And if you use it according to these suggestions of operation, you'll get great results. Your customers will have fantastic results. So, I guess that's what you're talking about, do's and don'ts. We'll try our best to document those in how to use document.
So James, what will be a big help for me, like I really owe you a lot. Like, I'm a distributor of Hayward. So can you look at this process flow Hayward made for me? And I'm a distributor of Pen Air. So Pen Air made me this process flow design. I told them to make me the ultimate design, meaning if a customer comes here, he's just gonna remove what he doesn't wanna do. And I'm also, what DuPont helped me make this sewage treatment process flow. So what happens is whenever my customer is here, this is like a hospital. I have the cure for everything. So they make me like a ultimate process flow so that when my customer comes, he'll be like, no, I'll just remove the aeration. No, I'll just remove the chlorine. So maybe you can help me make a IMA 75 iron manganese ultimate process flow which has everything. Recirculation, pre-oxidation, aeration, the sediment, so that when they come in here, I can somehow give them a little bit of guide, like, hey, are you doing this? Because this is the perfect one. But if you want to change something, it's all on you. At least I did my part in telling you what's the right way. Like how Jesus has the 10 commandments, right? We know the 10 commandments, but we break some of them partially. Maybe you can help me somehow, brother, on this.
Okay, I can give you some suggestions.
Yeah, like a design, like I just printed out my wall and pasted.
Yeah.
You see what I'm talking about? Yeah. So if you can help me make something like iron manganese filter removal system from start to end. So when they ask me these questions like, oh, can I mix anthracite DMI? Yes, you can do anthracite DMI. Oh, can I do a loop? Oh yeah, you can see my design, there's a loop. Oh, can I do, yeah, everything is there. Now just remove what you don't want. This would be like a game changer for me if you could help me.
I'll help you.
Yeah. You can already put there the must have 1.1 to 0.3 ppm. Like, it's all there. I don't have to say anything. You get what I mean?
Good.
Yeah.
Alright, ladies and gents. It's been terrific.
The activation,
We'll
carbon hypochlorite or
follow up with some communication with Alma, and we'll speak again soon. Okay?
Okay, before we end, Alma wants to say her, whatever you want to say, the calcium, just say it, then we can go already. Alma wants to speak.
Yes, hi, James.
She's not spoken, she's shy, so Alma will end the meeting with her. We'll end the meeting with her. Alma, what's your question?
No, I just want to ask about how to activate the DMI 65 because we are confused about between the calcium hypochlorite, which is the sodium hypochlorite is a granulated.
Liquid, yeah. Sodium is liquid, calcium
And
is
then sodium hypochlorite is a liquid form, right? So which one is the best one to be used for the activation of the media?
Sodium hypochlorite is the best.
there you go.
So our bag is right because it
Yes.
was written in the bag, sodium hypochlorite.
Yes, is the best way, and you'll get tremendously good results if you follow that step-by-step instruction. Very good.
Okay, thank you, James. Then we will wait the documents needed for the calculation and for the what do you call this, the dilution percentage.
And the process flow diagram, the
Yes.
ultimate process flow diagram.
The ultimate process flow diagram.
Okay? Okay, everyone, a round of applause for James and a big thank you.
Thank you.
Thanks, everybody.
Okay.
Lovely to have training with you. We'll do it again very soon. Okay?
Okay, brother. Thank you. Bye. Thank you so much.
So, okay na yung box natin. Clear.
And
Recording.
save mo ha. So, okay.
Nasaan yung bag ko?
Good effort, good preparation. Salamat, engineer. Nandito ka. Malaking tulong. So, pero, hindi mo pwede sabihin sa mga naka-off na ba no? Hindi. Hindi mo pwede sabihin sa industriya na hindi yan ito. Magkakagulo.